use color, but I just want to show you with some colors to show the difference between the lines. Okay, the first set of values, -2, 0, and 2 corresponds to my plots in red. Okay, I want to make a small change in the presentation over here. There was initially an X here, right? Can you please cancel it? And then draw one line down and put an X over here. So include the X, Y, Y, Y as shown. I think it's a little clearer. Okay, so let's take a look at the first set of coordinates. When x is equal to -1, for this equation of y equals to 2x, basically I multiply every single value of x by 2. So I get -2, I get 0, and I get 2. So I have 3 plots over here in red, and this is the equation y equals to 2x. Okay, then the next set of coordinates, again corresponding to the same x values. When x is -1, y is 0. Because -1 times 2 is -2, -2 plus 2 is 0. So you need to know how to fill in this table. So in blue, 0, 2, 4. 0, 2, 4. So we have three graphs over here. And going through the video, you will realize that hey, all these 3 graphs, they are parallel to each other. Let's do some counting of squares. Let's start with the blue color graph. Randomly choose a point. Let's say I choose this point. As I move to the right, I move the right by 1 unit. I move up by 2 units to this point. Can you see that? 1 unit to the right, then 2 units up. Anywhere on your first graph, you can choose any starting point. Suppose I start from here. 1 unit to the right, 2 units up. You see that? Same as our example 7, right? What was it? 1 minute to the right corresponds to 5 units downwards. This is the idea of a constant gradient. If we look at, for example, the red graph, let's maybe choose this point as a start. To the right by 1 unit, upwards by 2 units to get to this point. Maybe over here, to the right by 1 unit, upwards by 2 units. These 3 graphs have the same gradient, therefore they are parallel. If we extend the lines, they will never touch each other. Okay, so the number 2 keeps repeating itself. 1 unit to the right, 2 units upwards. 1 unit to the right, 2 units upwards. Looking at these 3 equations, do you see the number 2 that keeps appearing? I've actually highlighted it for you. Can you highlight the number 2 as well? Because that number in front of the x tells us something about the gradient, which we will find out more later on. Okay, then in your second exercise, same thing, the x over here, please cancel it off. Okay, this x, cancel it off. Draw a line down, x, y, y, y. Okay, let's take a look at the corresponding graphs. The blue, the red, and the green graph. Are they all sloping in the same way? Sloping. Let's start with the red graph first. It is sloping up or down as we move from left to right. So you place your finger on the left hand side. Are you going upwards or downwards? Upwards. You need to identify this and you need to be able to tell whether it's going up or down. Okay, so correct. Next graph in blue color. Going up or down? Up. Good. Green graph. Going up or down? Green color. Up or down? down. It's going down. From left to right, it is going down. Okay, remember earlier on in the previous exercise, you highlighted the number 2? That number 2 was the coefficient of x. Remember the word coefficient? It is the number in front of the x. What is starting from the red graph, what is the number in front of the x? What is the coefficient of x? 1 over 3. Okay, remember this number 1 over 3, huh? Next, the blue graph. What is the coefficient of x? 1. It's not 0, huh? There is an invisible 1 over here. 1 and 1/3. Are they the same number? If they are not the same, then they are not parallel. Can you see that they are not parallel? The red and the blue graph, they cut each other, right? So they are not parallel. How about the green graph? It is sloping downwards over here. What is the coefficient of x? Negative 1/3. It is different from 1, it is different from 1/3. So obviously they cannot be parallel. Okay, let's see how much you can make a smart guess. What do you think determines whether a graph slopes up or slopes down? Whether what is negative or positive? Whether the coefficient of x is positive or negative. Do you think so? So based on what Sean said, what does a positive coefficient tell us about the slope? Yeah, positive coefficient. Look, this is positive 1, this is positive 1/3. If it is positive 1, positive 1/3, it will go upwards. What about negative? Then it will go downwards. Okay, so that's the gradient over here. Based on the sign, whether it is positive or negative, of the coefficient of x, I can tell straight away whether it slopes up or slopes down. Next thing that we can tell is the y-intercept. Do you remember what y-intercept is? Okay, y-intercept is basically where your graph cuts the y-axis. Do you see that all 3 graphs over here, they cut at the same point? What is this value over here on the y-axis? 0, 1, right? Apparently all these 3 graphs, they have the same y-intercept of 1. Can you look at your equations of these 3 graphs? Is there anything in common? What is common? The plus 1. Plus 1, plus 1, plus 1. What do you think this constant term, this term without the x, what does it tell you actually? It tells us the y-intercept. Based on this, the 1, 1, 1, basically the constant inside the equation, the number that does not have the x, it tells me where it cuts the y-axis. Why would that be so? What is so significant about the y-axis? What block is this? What block is the y-axis? Block 0. Now, block 0 means x equals to 0, isn't it? What happens when x equals to 0 here? Y equals to 1. What happens when x equals to 0? Y equals to 1. What happens when x equals to 0? Y equals to 1. That's why they all intersect over here. So there are a few things that we can tell. The first number in front of the x tells us the gradient. Does it slope up or does it slope down? The constant term tells us the y-intercept. Next, same thing, change the presentation of your table. We're going to find out the shapes of 2 more types of graphs. They are called special cases over here. So same format, we've got x equals to -4, x equals to 0, x equals to 2. But we're not going to consider the equation of y equals to 2 first. When y equals to 2 and when x equals to -4, what is the corresponding value of y? When x equals to -4, what is the corresponding value of y? Is there anything to substitute? Before this, in your previous 2 exercises, they all look like this. Y equals to, for example, 1/3 x plus 2. Then you can sub in -4 here, right? But here, there isn't any more x. It means it is independent of x. x does not matter over here. We are trying to find the value of y to fill in all these blanks. But now they are telling me that, hey, x is not a factor. It doesn't matter what x is. So what's the value of y? 2. Well, what do you think is the next blank? Also 2. Over here also 2. So can we plot this first? When x equals to -4, when x is -4, y equals to 2. When x is equal to 0, okay, when x equals to 0, take note, this means our y-intercept. X equals to 0, y equals to 2, x equals to 2, y equals to 2. So we get a horizontal line. Y equals to 2. Okay, before I go on to the next line, remember we also mentioned the coefficient of x tells us the gradient, whether it's slope up or slope down, or it is flat. In this case, it is flat, or whether it is vertical. Okay. So we also say that the coefficient of x, look here, the number in front of the x tells us whether it's slope up or slope down. What is the number in front of x over here? What is the number in front of x? Is there an x term? Don't have. I can rewrite this to become y equals to something times x plus 2. What is the something over here? What number must I place in this box? 0. 0 times x is 0. So what does this tell me about the gradient? The number in front of the x is the gradient. So what is the gradient here? The gradient is 0. For this horizontal line, the gradient is 0. It is neither sloping up, nor is it sloping down. Slope up is a positive number. Slope down is a negative number. If it is not up, not down, so it's not positive, not negative, it must be 0. No choice. Okay, next equation of y equals to 0. I'll use another color. When y equals to 0, and given that x equals to -4, what do you think is the value here? It's still 0. It doesn't matter. It doesn't matter what the x values are. Y is always going to be equal to 0. So 0, 0, and 0. Draw a line. And this is my line, y equals to 0. Does this bring back memories when I tell you about level 2, level 0? Same thing. Level 0, level 2. And the last one? -3, -3, -3. For all these cases, y equals to blank x minus 3. This is all 0. The gradients of all these horizontal lines are 0. Now you notice that I included the y and the x in the 2 axis. I think it wasn't printed. Can you include that? Okay, let's fill in the blanks at the bottom. What is the shape of a graph? Of the graph? They are straight lines, yes. What is the direction of the graph? Is it sloping up or sloping down? Neither. It is not sloping up, it is not sloping down. So we say it is horizontal. What is the steepness? It is not positive, it is not negative. So we say steepness, which is the same as gradient, is equal to 0. And our conclusion, when y is equals to a number a for example, where a could be 0, could be -3, could be 2 in this case. When we have the graph y equals to a, it means that it is a horizontal line passing through y at a. Now if a happens to be 2, then it passes through y equals to 2. The y-axis at value 2. If it is y equals to -3, it is a horizontal line passing through -3. And the next one, y equals to 0, refers to x-axis. Oh, sorry, I should say horizontal axis. Okay, this? Okay, next. Since you've done horizontal graphs already, right, what do you think is going to happen next? Yeah, vertical. I think so too. Okay, change the format over here. Include your x and y axis. So now instead of x on top, they give us the y value, which is 3, the y value of 0, the y value of -3. But for each of these cases, they are telling us that x is equal to 2. There is no substitution to be made. Regardless of the value of y, we are going to end up with x equals to 2 for the first row. This equation is x equals to 2. So all the x values are 2. Okay, so we got x equals to 2. This is the line, x equals to 2. We've got y equals to 3. 1 point over here. We've got y equals to 0. We've got y equals to -3. Join them up. This is the line x equals to 2. Always have to label. So I think you can do the rest yourself. Zero, 0, 0. No matter the y value, my x value is always 0. And the last case, -3, -3. Shape of the graph. Again, straight line. What is the direction? It is vertical. Okay, what about the steepness? Which is the gradient. So what is going to be in this blank? I'll bring you back to 2 pages before, back to this question. You don't have to flip, you just watch. Compare the red and the blue graph. Compare. Which one more steep? Blue or red? Which one more steep? Blue, right? You can imagine it's harder to climb up the blue mountain and the red mountain. Compare the two coefficients, 1 versus 1/3. How are they different? Give me a statement relating 1 and 1/3. Which is greater than which? 1 is greater than 1/3. And that over there is the relationship between the steepness. The greater the coefficient, the steeper it is. So can you imagine? A line that is more steep than the blue line, more steep. An example will be gradient 2. For example, y equals to 2x plus 1. It's more steep. Can you give me an example of a line that is more steep than y equals to 2x plus 1? 3? Can, right? More steep. Let's choose a bigger number. Y equals to 100x plus 1. Can you imagine that will be very, very steep now? How about bigger? Y equals to 1 million x plus 1. Super steep, right? Can we go bigger than 1 million? Yes. What is the biggest number that you know? Something that is really humongous. Very hard to imagine what this number is. Infinity. When we go to infinity, when the gradient is infinite, it means it is super duper steep, right? What will a super duper steep graph look like? Vertical. Okay, so as we increase, the gradient increases and increases and increases until this point, the gradient is now infinite. But what if we go beyond that? Is this still infinite? No, yeah, it is now negative. Then it becomes negative, 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 0. Positive, 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 infinite. Get it? Now, we don't usually say infinite, we call it undefined. Okay, so the gradient we can write over here, undefined. It is so big, it is hard, it is very difficult to imagine what this number is. And now, our conclusion. X equals to A means a vertical line passing through X at A. So it is like a block. When I say X equals to 1, I mean block 1. It passes through 1. When X equals to negative 99, it means block negative 99. So a vertical line passing through negative 99. So next, X equals to 0 represents or refers to the y-axis. That is our block 0. Okay, to summarize everything that we have learned in the next page. Generally, a graph for a straight line, it looks like this. Y equals to mx plus c. Where y and m, they are our variables. They are the ones that can change. When we plot a graph, we put x and y over here. When x equals to something, y equals to something. X equals to something, y equals to something. Okay? Now, the number in front of x, rather, the coefficient of x. What does this tell us? Gradient. It tells us whether it slopes up or slopes down or is horizontal, depending on the value of m. Okay, recap, see how much you remember. When it slopes up, what is the value of m? What is the range of values for m? Positive, negative, or 0? Positive, yes. When it slopes down, what is m going to be? Negative. When it is horizontal, what is x going to be? 0, good. And the final one, c. This is our y-intercept. Y-intercept, where it cuts the y-axis. And that happens when x is equal to 0. Right, in the second example in this set of notes, when x is equal to 0, I don't care what the gradient is. The gradient times 0 gives me 0. Then I plus c. That will be the y value. When x equals to 0. That will be the y-intercept. The next type of equation looks like this. Y equals to a. So this is going to be a horizontal line. The gradient is 0. And I've shown you why it is equal to 0 because y equals to a can be written as y equals to 0x plus a. They are the same thing. Y equals to a and y equals to 0x plus a. So in this case, it is of the form in type 1, where our m value is 0. So gradient is 0, and we have the intercept at a. So it passes through the line, passes through y equals to a. The final type is our vertical line, x equals to b. The gradient is undefined. It is a vertical line passing through x equals to b. And we notice that for all these cases, the highest power of the variable is 1. We will not get x squared. We will not get x cubed. Maximum x power 1. Then we have a straight line. Okay, and this is the summary of what we have talked about just now. When the m value is positive, it means it slopes up. So right over here, slopes up. When the m value is negative, it means it slopes down. So the greater the value of m, the more steep it gets, such that it goes until infinity. Then it's super steep. It becomes a vertical line. So the same will be for the opposite. The more negative you get, the steeper you get in the other direction. This is very, very negative slope. And we've also got our y-intercept. Okay, the y-intercept will be the constant term. Now let us try exercise 5. We are supposed to be able to look and tell what a gradient is, what a y-intercept is, and what a graph looks like. Okay, so let's start with the first one. We will always, okay, please change this y over here, y-intercept, change it to vertical intercept. Sometimes it is, most of the time it is y. Sometimes it is not y. As shown in question C, there is no y term over here. Okay, so vertical will encompass all of them. So I'll just, for convenience, I'll put it over here. Y equals to mx plus c, where m is gradient and c is vertical intercept. This is just for convenience. Okay, now, first question. Y equals to 2 over 3x plus 5. What is the gradient? What is the coefficient of x? 2 over 3. And now I want to skip to direction. Sloping up or down? Up. Slopes up this way. The y-intercept? What's the y-intercept? 5. The y-intercept happens when x equals to 0. So you can just put in x equals to 0 and you are left with 5. Okay, part B. What is the gradient? I want the coefficient of x over here. What's the coefficient of x? Is it half? Or is it negative half? Coefficient of x. So you see, is this of the form y equals to mx plus c? Not exactly right. But can I make it y equals to mx plus c? Can. This becomes y equals to negative half x minus 4. Can you see that they are the same? Okay, now is it clearer what the gradient is? So gradient is negative half. Y-intercept, negative 4. So if the gradient is negative half, it slopes downwards. Okay, I will skip C first so that I won't confuse you. Let's deal with all the x and the y's first. So part D. Y equals to negative 6. Can you imagine what this graph looks like? Y refers to level. Level, negative 6. What kind of line is it? Vertical or horizontal? Vertical or horizontal? Horizontal. level -6. So the gradient, 0. There is no x term. See, don't have x. No, so the coefficient of x is 0. That's why x disappeared. So that will give us a horizontal line. And then the y-intercept is -6, the constant term. Next one, x equals to -4 is a vertical line. So if it is a vertical line, our gradient is undefined. If it is undefined, it is a vertical line like this. And the y-intercept, is there a y-intercept? Let's see the graph of x equals to -4. So if -4 is over here, this is the line x equals to -4. Is it ever going to cut my the y-axis? No, it's not going to cut the y-axis. It is parallel to the y-axis. So, none. Or NA. There is no y-intercept. Okay, next. Part F. What is the gradient? Is it 5? Is this of the form y equals mx plus c? Is it y equals mx plus c? No, I don't have y here. I have 2y. What should I do? Yes, divide by 2. Y equals to 5 over 2x minus 3. So what's the gradient now? 5 over 2. So it slopes up. Intercept, -3. Okay, M. What is the gradient? Good. Intercept, 3. Sloping up or down? Down. Okay, now we come to part C. So instead of y, they have v. Instead of x, they have t. So the gradient over here will be the coefficient of t. That is -3. So it slopes down. And the intercept will be 24. Can? Okay.